Hello mathematicians, welcome to the 1.2 video. In this we will be going over pages 1, 2, and I will be talking about page 3. Completely ignore page 4, that's just there for fun. Alright, so let's get started. This first example is dealing with bees, with a very large bee population, and we can see, where's my highlighter, that B of t is the bee population, in thousands, T months after April 1st, 2012. That's what we can see below. Let's just answer some of these questions. But first, what do they mean? So when it says, where is my pen? Haha, there it is. First question, when it says find B of 3, that's like asking, hey, when your x value is 3, what is that y value? And then right here, when it says explain what this function value represents in the context of the problem, that means sentence. Whoops. There we go. So we're going to be writing a sentence for all of these problems, just putting them in context. So let's see, if I take a look at my graph, it's still a lightsaber, I forgot. If we take a look at the graph, let's see, when x is 3, my y value looks to be all the way up here at 15. So I'm going to mark that in just so that I can see it. So it'll be like right there. And we can say that B of 3 is equal to 15. Don't just write 15. I would like you to use proper function notation, and that's what this looks like. So B of 3 is equal to 15. And what does this exactly mean? So with an input of 3, or 3 months after April 1st, 2012, we got the answer of 15, which means the bee population was, it's not just 15 bees. Remember, this is in terms of thousands, so this is 15,000 bees, which is, to be honest, far too many bees. All right, let's keep on going. So the next one says, find B of 0. So it's like saying at month 0, which is right here. I'm marking it on black, in black, pardon me, on the graph. So B of 0 is equal to 10. So you can write, I guess, 0 months after April 1st, or you can just say on April 1st, 2012. That might make a little more sense contextually. The bee population was not just 10, but 10,000. And you can also write out the word thousand if you'd like. Now the next two are a little bit more exciting. There we go, just moving that up a little bit. So solve for B of t is equal to 13. So what this is doing is this is giving us our y value, and we want to find the x values that go along with it. So I'm going to be drawing this on the graph in red. So I'm looking for when my y value is 13, so B of t is 13 right here. So if I draw a line, dotted line, across the graph, I see this happens in two spots. This happens right here and right here. So we're given that y value, we're given that b population, and it looks like we have that specific population of 13,000 after 1 month and 5 months. So we can say that B of 1 is equal to 13 and B of 5 is equal to 13. In this case, it's okay to have more than one value. So we might write the bee population was 13,000 the 1st and the 5th month after April 1st, 2012. Now, if you wanted to keep the sentence structure consistent with what we had done previously, and you wanted to say the 1 month and 5 months after April 1st, 2012, the bee population was 13,000, that is okay. That means the exact same thing. That is perfectly acceptable. Do what you want to do there. Let's see, moving on to part D, similar type of thing, b of t is equal to 3. So we're looking to see when that y value is 3. So if I draw that on the graph, looks like that only happens at one spot at 8. So we can say that b of 8 is equal to 3, or 8 months after April 1st, 2012. The bee population was 8,000. So again, you could have said this, or you could have said the bee population was 8,000 the third month after April 1st, 2000, or pardon me, the 8th month after April 1st, 2012. So that works. So that's kind of just making sure you're putting everything into context. Lastly is state the domain and the range. So we're going to start bringing range into our questions now. And just a reminder, range is in fact y, and range, I'm going to make a side note here. Moving this around. Okay, so domain goes from left to right. Ooh, I ran out of space there. Range goes from bottom to top. I see a lot of people using y values and even the correct y values, but just in the wrong order. So I want you to be careful of that. Start with the very lowest values that you have and go all the way up. So for us, domain and range, let's look back at that graph. So the domain, I see that the most left, or the smallest x value, is 0, and it ends right around here at 9. So it's going to be from 0 all the way to 9. There's no breaks in between. Oop, I forgot that was still on. Ooh, no, come on. Okay, so this is going to be from 0 to 9. Now, since those are closed points, we're going to say those are brackets. And then for range, range is bottom to top. So my lowest y value here is at 0, and my highest y value is up here at 15. So that's going to be from 0 to 15. And again, since those are closed points, we're going to use brackets. But you might be saying, Ms. Twain, what if they're not closed points? What's going on? Well, let's look at the next page. On the next page, we have many, many graphs. We are asking, are things functions? If they are functions, state the domain and range. If they are not functions, don't worry about it. But as we can see here, we have a few different scenarios. I see over here a closed point, I see over here an open point, and I also see some arrows. So what does that mean? Well, if you have a closed point, that's the same as that greater than or equal to. That's the equal to piece. So that means we're going to be using brackets there. Or if you see an arrow or an open point, that's like a not equal to. So that would be like just like having that without the line underneath. So that's going to be the same as parentheses, because that arrow also implies infinity as well. So closed point, brackets, arrow or open point, you're going to use parentheses. So let's take a look here. First thing we need to check, is this a function? I'm going to be using my lightsaber for my vertical line test. As I run over my vertical line test, if it touches my lightsaber more than once, it is not a function. So as I go over figure 2, I go, oh no, it's touching my lightsaber in 2 places. This means it's not a function. Every input has more than one output, which is bad. We know it should have exactly 1. So is this a function? No. You know what that means? We don't have to find the domain and range. Cool. Done with that one. Figure 3, I'm going to leave that for the Go formative for tomorrow in class, so we're just going to ignore that for now. Let's take a look at the bottom 2 down here. So I'm just going to check to see if both of them are functions first. So over here, I'm going to run my lightsaber. And now there is a break in between, but that's okay as long as every output has exactly one, every input has exactly one output, we're good. So this one, yes, it is a function. Now let's check the other one. Now the other one is a little bit more different than we're used to. This is a discrete graph or scatter plot. It in fact is just a bunch of points. But as I go through, I noticed that no points line up with each other. So you know what that means? That means it's a function. Yes. Okay, so let's go back to figure 4 and take a look at domain and range. So remember, domain, that's our x values, it's from left to right. And I see over here we have an arrow, which means it's going on and on and on forever in this direction. But over here is negative infinity for our x values. So we're going to start this with a parenthesis, negative infinity, and move as far as we can go. So we can go to here, here, here. Oh, we have a break. So that is at 1, and that is an open point, meaning we can get really, really close to 1, but we can't be equal to 1. So we're going to go comma 1 with a parentheses. But we also continue on, so we can use these x values, or we can start over here at what looks to be an x value of 3 with a closed point, so we can be equal to 3. And then I see another arrow, so we're going on and on and on forever. So that becomes, oops, I don't know what just happened. This, why do I have a, oh, there we go, okay. So this should be a bracket because it is a closed point, go all the way out to infinity. So that's going to be our domain. And then we're going to do the same thing with range. We're going to start at the very, very bottom, which is still negative infinity, and move all the way up to, that looks to be 2. And again, that is an open point, so we're going to be using a parenthesis there, to 2. And we can continue going. So even though there's a break, that's okay. We can continue going from, looks like 4, all the way up forever and ever. So that's going to be with a bracket 4 to infinity. So problem number 5 is fun just because we don't interact with it very often, and this is probably the only and last time you'll see this. But how do we talk about domain and range here if it's not continuous? There's just a bunch of points. Well, we get the honor of listing all of the x values in order from least to greatest. There's not even really a way to do this using interval notation. So what we do is we just kind of steal the curly brackets from set notation. My curly brackets are terrible, sorry. So we'll list our x values from least to greatest. That'll be -6, -4, -2, 1, 2, 3, 4, and 6. My right curly brackets are way better than my left ones. So we just listed all of our x values because those are the x values that are possible. We can't use -5, we can't use 2.5, we can't use anything in between. And we'll do the same thing for the range, except for left to right. We'll be going bottom to top. So let's see, that'll be -7, -5, -2, 1, 3, 5, and 7. So again, I'm not going to give you any problems like this normally. I just kind of wanted to show you what that would be like. Okay. Here we are. On the next page, there are many questions, most of which I have put on the Go formative, but I want to explain what the question is asking, just because some of them are a little bit confusing, and I'm not going to make you do all of them. So let's move on. Here we are, our last page, page 3. I'm actually going to only be doing one of these problems with you. For the rest, I'm going to either explain what it's asking or tell you not to do it. So for problem A, it's asking if this is your x, what is your y value? F of b is asking the exact same thing, but in a different way. So evaluate f at 4. That's like saying find f of 4. For C, don't do it. Don't worry about it. For part D, when it says, for what values of x is f of x equal to 0? That's very similar to the front page. You're going to have f of some number is equal to 0. You may even have more than 1. For part E, when it says state the zeros of x, it's going to be x is equal to, where are those zeros? And then what are the horizontal intercepts? Now, horizontal intercept, that's just an x-intercept. An x-intercepts we always write as a point. Now, you may be looking at this and going, Ms. Twain, I think D, E, and F are all asking the same thing. Yes, yes, they are. You should be getting very similar answers for D, E, and F. It's just the notation that you are using. So please make sure that you are using the proper notation. Part G, what is the vertical intercept? That's asking about the y-intercept. So again, please write that as a point. Now H is the only one I'm going to do with you here today. It says solve for f of x is equal to 4, and then state the solution set. So we're not going to be using solution sets too much right now. We'll use them more in maybe a month or so, but I wanted to show you kind of what that is. So here there is in fact multiple answers, but instead of using function notation, we're going to be writing all of them out. So if we were to use, let's see, f of x and -4, so that's when y is -4, what is our x value? And that happens here, that happens here, that happens here. So this happens at 3 different spots. So instead of saying f of -7 is equal to -4, like our function notation for part D, I'm going to be listing these in a solution set, and that's with curly brackets, and we're going to list these from least to greatest. So that'll be -7, -4, and 3. So when I'm asking for things in a solution set, those are all the possible solutions we can have within these curly brackets from least to greatest. All right, let's see, for part I, don't worry about it. Part J, don't worry about it. K and L are just asking for domain and range, so practice like what we've been doing. I look forward to seeing you all tomorrow. Enjoy the rest of your day.